I uploaded a video several weeks ago which featured this lovely 1980s Rolex GMT Master Pepsi, and in that video I demonstrated its strip down and rebuild, and after some tweaking the performance was very good. So if you saw that, you might be wondering why this watch has not been returned to its owner yet. Well, there's a very good reason. You see, as you can imagine, I always test the watches I work on quite extensively before reuniting it with its owner, and I'm afraid this one didn't pass the test. The problem I found was with the calendar, which worked normally most of the time. However, I did notice that on occasion, when advancing the date, the calendar ring did not snap over as it should do, but rather it just moved as a gradual process, taking much longer than it should. Now, with many different watches, this would be normal behavior. A calendar may take quite some time and start moving before the snap over. For example, this Omega coaxial movement takes around 50 minutes to complete from the point the calendar starts moving until completion, and this is why with some watches it's advisable not to operate any rapid calendar change facility within the time period of the changeover. But this particular movement has been designed so that the calendar snaps over without any prior movement of the calendar ring, and if the hands are aligned correctly, the calendar should change over within a minute or so of 12 o'clock. So I'm going to take the dial and hands off and investigate the calendar works to see what might have gone wrong. So here we are with the dial and hands removed, and I can demonstrate what's happening by manually advancing the calendar. Now once this is fixed, I will show you the difference in how it should operate, but for now please observe the finger here on the calendar driving wheel. Notice how it's not snapping over the calendar, but rather is pushing the calendar ring along. Now I've already suspected what the issue is, and I have had the part on order, and it has arrived. But first let me dismantle the calendar works further, and I'll show you how it operates. Now it all starts here. This is the cannon pinion, and it's directly attached to the train of wheels. In fact, the minute hand is installed on the cannon pinion, and so this turns once per hour. But the cannon pinion also drives this wheel. It's called the minute wheel, and this wheel provides a gear ratio between the cannon pinion and this wheel, called the hour wheel, so that it turns a full rotation every 12 hours, and in fact the hour hand is installed to this wheel. But notice there is an extra layer of teeth on the hour wheel, and these teeth will directly drive the calendar driving wheel at such a ratio as to cause it to turn once every 24 hours. The calendar driving wheel directly turns the calendar display ring, but this one has an assembly with a cam, and as the wheel turns, the cam will cause this yoke to be pushed away, and as it's under tension from quite a beefy spring, this tension builds up considerably as the cam is rotated until the yoke reaches the drop point on the cam. Tension is released and the yoke causes the cam assembly to turn independently of the calendar driving wheel by several degrees, and this causes the finger to push over the calendar display ring. However, if there is too little tension, then the yoke will reach the drop point on the cam, but the lack of tension will not cause the cam assembly to turn. The calendar does eventually turn over, but it's not working as intended. So having said that, if there is too little tension, then the most likely culprit will be the spring which provides that tension. I've taken out the original spring, and it actually didn't take much effort to completely break it. And here's the new one. So, in theory, once I've replaced this spring, the calendar should be working as designed. And here we are. That seems to have done the trick. Just to remind you, here is a before and after. Notice the difference? The finger now kind of kicks the calendar display ring over rather than gradually pushing it. Okay, I will put this back together, and as somebody did ask in the comments of the previous video, stay tuned and I'll demonstrate the water resistance test, how I check for any case leaks. So here we are doing a wet test, and this doesn't make a watch water resistant, but rather this operation lets a watch repairer know if there are any leaks, and if so, where those leaks are, so that they can be dealt with. There are three main points where water ingress could occur: the crown, the case back, and the glass. The watch is placed in the chamber, but not yet immersed in the water. Pressure is built up in the chamber, and the theory here is that if there are any leaks, then the compressed air will be forced into the case through the problem area. After a few minutes, the watch is plunged into the water and the compressed air is released. If any compressed air was forced into the case, then the air will also want to escape whilst the compressed air is released. If this happens, then you'll be able to observe the air escaping as a stream of bubbles will occur as air shoots out of the case. The origin of those bubbles will be the place to examine in order to fix the leak. And the nice thing is, because air is escaping, water cannot enter, which makes this a relatively safe operation. But this watch has passed the test, so now I can dry it off and I'll give the calendar one last test. Well, that's it. The watch is back on test, but it does look as if we're done with this job. Let me know your thoughts in the comments below. Thanks for watching, and I'll see you next time. Take care.